Hi, this is CTO Charlie from Industrial Arm Works. We are at andahammer.com. That's like an arm and a hammer. I'm going to compile the new Linux 3.7 kernel for the Mini2440 from scratch, downloading sources, tools, and everything we need. I'm not such a heavy Linux user that I know all the special directories where tools and things get hidden. I tend to put all this stuff into a directory in my home directory and keep it separate. I'm going to start right out by making a directory to put everything in. I'm going to call it Mini2440 kernel. I'll be cutting and pasting just to avoid making a lot of typos and messing up what we're doing. Into this one, I'm going to go, let's change directory into Mini2440 kernel. Make a couple of additional useful directories there, just from experience. Now I'm going to need one for a tool chain. This also helps me keep the tool chain separate for different devices. And we're going to need one for modules, which we'll have to make at least once. I'm going to take there they are. I like the list view, so I do a Control-2 when I get into just about anything here. This is the DVD for the Mini2440, so I'm going to take our GCC 4.4.3 tool chain and move it over, and that should be about done. You can also get that from the friendlyarm.net downloads from the ones on our pages or from Baidu if you read Chinese. That looks good. We're going to get a couple of other sources we need. We need the kernel sources from kernel.org. And as you probably know, Linux technically is the kernel. Things built on top of it, various file systems, Android, Qtopia, even Debian, things like that. Those are separate from Linux. Those are running on the Linux kernel. So as you can see, this goes pretty quickly. The Mini2440 is a 400 megahertz ARM9, 32-bit wide. Not too shabby. 64 megabytes of RAM. Seems small to people these days, but we can actually run from an SD card. We can run Debian with X, tkinter, and Python, and that does quite well. I'm going to get some stuff from the Ocelius Pengutronics projects, because they have already figured out how to use the 3.7 kernel on the 2440. And we're going to be applying some patches from them. At least I am. Now we'll unpack these tape archives. People actually call them tarballs sometimes these days. I don't know how tarball evolved from tape archive. But there we go. It's pretty fast. I will uncompress the source code. Now this is a 3.4 gigahertz 8-core AMD based machine. Let's see, I'm going to unpack the tool chain, and it's actually going to copy, you can see, into the tool chain subdirectory here. So this is a Tiger Direct bare bones thing with a decent motherboard, a small solid state drive which we're running off for this project, a terabyte hard drive, and a reasonable amount of RAM, and dual displays that were on sale. I think the whole thing can be probably done for about $450. We're going to make a directory To store these patches, we'll put it in the Linux sources. Make sure we haven't missed, sorry about all the popping and lip smacking. I used to do a lot of public speaking and teaching, but I've lost the habit. Now I've got this, what the radio people call, I'm popping my P's, pop, 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 and smacking. Let's see, bad habit. So patches, I don't think we have to move into that yet. We're going to move some of this. We're going to copy the kernel config from the Ocelius people, Pengutronics. We're also going to copy some patches they have right here into our patches subdirectory. P command not found. I guess I probably left something off there, didn't I? Back at the beginning. Let's go all the way back to where there needs a C in front of that P to make it copy. There we go. We need to export our path. Normally I would put these, I would find these exports I need, put them into a script so that I could run them whenever I need to do this particular project or use these compilers and things. This one points to the tool chain, so it just adds the tool chain to the path. The architecture environment variable has to be set. We're going to declare that to be ARM. And the cross-compile environment variable will be set to point to our compiler, which is the usual GNU EABI for ARM. Let's move into the source directory, which is where the config files and things are as well. And we're going to use Quilt, a utility or tool, to take care of some of that stuff from Pengutronics. There's done. Then we can make the menu config file. Done. And then we'll go ahead and see what it looks like if we make the menu config, the graphical version. And I happen to know that this kernel already has the sysfs set for the GPIO, which is good. I can see here it also has I2C, SPI, a bunch of other stuff. This 3.7 is a big advancement over the 2.6. A lot of the stuff was hidden down various layers through device and character drivers and all that. Now it's all brought out the top. So I'm going to leave that pretty much like it is. I'm tempted to turn on Dallas one-wire support, but I'll do it later. I get a chance to play with it. File systems, we have support. Let's turn on ext3. That's commonly needed. Let's turn on ext4. JFS, I think I'll leave that out. Interesting. Okay, so we can now do a make. I'm going to put time in front of this, and then the bash will tell us how long it took. Make with 8 cores. I'm going to just give it 12 threads. I think that'll feed it fast enough. And this is going to be on an SD card on a system run by U-boot, so I need an uImage. And let's see how long it takes. Now we have a screen capture at 15 frames per second going on here with a little program called Kazam. So that's going to be cutting up into a lot of time. I will note after I post this how long it took without. I'll do a make clean and a make, and we'll see how long it took without the screen capture going on. But my past experience has been it ranges from 55 seconds to 90 seconds on this system. I have heard that these AMD processors, when they're doing jobs like compiling, where they're just basically processing strings of text and building tables, are as fast as the best of the Intel. So if you do a lot of kernel experimentation, driver writing or modifying, a lot of fast iterative work on code, these things are fantastic. It's not a gaming machine. It does have a graphics card added, but and it's running 2 monitors beautifully. But it does this kind of stuff very well. If you set up a network file system, NFS, and you can also set uboot to boot the kernel over TFTP, you can keep everything on the host here. Here we are, 1 minute 37 seconds with the video recorder running. So, a minute and a half with the video recorder running. Let's see if we can make the modules. I haven't tried this before. Let's try. That looks right, I think. No rule to make target module install. I don't know what I'm doing wrong there. Maybe I'll post a little addendum when I put up the video. But basically, this would produce the modules as individual files in the modules directory. You would then copy them into the path for the root file system on an SD card or on your drive if you're using NFS. I wanted to mention though before I'm done that if you do want to use a network file system and TFTP, you can set up Eclipse to do all that for you. So you could compile this fast, have Eclipse target those files on your host, never have to fiddle around with slow transfers or taking SD cards back and forth to a Mini2440 or one of the 6410s or 210s or 4412s. And plus you get the debugging over GDB of single stepping through C, ARM assembly language, Python, whatever you want to use. I happen to like to use Python with X and tkinter, and with a 64 megabytes of RAM, which seems small these days. On the 2440 there's, let's see, with Linux loaded, Debian, Xserver, tkinter, and Python, there's at least 24 megabytes left of space for application work. Alrighty, well, thanks for looking.